Hello everyone, welcome to this Aldeck Riviera-PRO video. My name is Chantel, and I'll be going over how to use Xtrace with Advanced Dataflow. Xtrace is a command used to create a report for whenever an unknown value occurs during simulation. It can track X values, U values, don't cares, and any other values that you specify. When an Xtrace report occurs, you can actually cross-probe with the Advanced Dataflow tool to bring up the Dataflow window and get a visualization of your simulated model at the current simulation time. From here, you can use the Dataflow window to help pinpoint in your design where the source of the unknown value originated from. So now let me go ahead and demonstrate these two together. Right now I have the short circuit sample design opened. This can be found in the examples folder of Riviera-PRO, and then go to Tools, and then Xtrace. This is just a simple example of a 4-bit counter getting its output from 4 D flip-flops. And I'll be using the Verilog version of the sample design. Now I'll just open up the RunMe macro to show what's inside of it. The first few lines are the usual commands for setting the working directory, loading the procedures, creating the project library, and compiling the project's source files. The asym command is used, and the Advanced Dataflow argument is passed with it. This is necessary in order to be able to utilize Advanced Dataflow during simulation. And now we have our Xtrace command with a number of arguments passed with it. Hold stops the simulation whenever Xtrace finds a value on the trace signals. In this case, it looks like the signal Q is being traced. Stop condition specifies the number of times an Xtrace value occurs on a signal before Xtrace stops reporting subsequent occurrences. Next to stop condition is the number 0, meaning that there's no limit and all occurrences on the signal will be reported. The drivers argument adds info to the report about the drivers of the signals experiencing an unknown value. And then we have the Advanced Dataflow argument, which will allow us to add the Xtrace signals to the Dataflow window. The rest of the commands below add signals to the waveform viewer and run all of the simulation. Now that we know what this macro does, let's go ahead and run it. Okay, it looks like we've hit our first hold in our simulation. As you can see in the console window, there are 2 Xtrace messages. In these messages, you can see the time when the unknown value occurred, the name of the signal that this happened to, the value that was traced, and then the driver's name along with the value the driver assigned the signal. Let's also take a look at the waveform. We can indeed confirm that the 3rd bit of Q is getting an X value, leading to the entire value of Q becoming an unknown value, depicted by this question mark. Now, we can already assume what's happening, but let's keep running the simulation. And once again, the simulation stops, and we have the same signal getting the same X value, which is still being caused by the same drivers. I'll go ahead and keep on running, and we get another stop in our simulation with the same things. So I'll click Run one more time. And it looks like we've reached the end of our simulation. There's clearly a repeating pattern of what's wrong. So now let's take a closer look at what's happening. If you remember earlier in this video, the Advanced Dataflow argument was passed through asym and Xtrace in the macro. So that means I can add these Xtrace signals to the Dataflow window, where I'll be able to visually see where my signals get their values. I'll expand a bit more to reveal more of the modules and connectivity. And now let's do some signal tracing. To the very right, we have Q as the final output. Working backwards, we can see that Q gets its value from these 4 assigned statements. And then, these 4 assigned statements get their value of Qtemp from these 4 D flip-flops. And it looks like no X or other unknown values pop up at this point, only towards the end where the assigned statements are. With Xtrace, we can see which of these assigned statements are causing an issue. The Xtrace messages show that assigned number 26 and number 28 are the drivers. it looks like these two assign statements are assigning two different values at the same time to Q3. Now let's figure out where the problem is in the design. In the Advanced Dataflow window, I can right-click on the statements to view their instantiation. I'll first do assign number 26. Doing this brings us to the counter 4B module on line 26, showing Q3 being assigned the value from the third bit of Qtemp. Now let's go back to Dataflow, and I'll do the same thing again for assign number 28. And we're back to the same counter module, this time at line 28, and it looks like this is also assigning Q3, but it's getting its value from the first bit of Qtemp instead. So now that the issue has been identified in the design, let's go ahead and fix it by changing this to Q1. I'll now end the simulation, but before I run the macro again, I'd like to point out that when simulation has ended, an Xtrace report will be generated in a .txt file. You can see in the File System tab within the Sample Designs folder that there is an Xtrace file. When I click on it, the full report of all the Xtrace occurrences are listed. This is great for when you need to share this data with other project members, or if you keep a log of these occurrences after every simulation. Now I'll go ahead and run the macro once again. And it looks like our simulation ran smoothly this time. No Xtrace messages means no unknown values occurred. Being able to use Xtrace and Advanced Dataflow in conjunction with one another provides an effective way for tracing unknown values that occur during simulation. These two tools make it a lot easier to pinpoint the root causes of the unknown values. This can save time fixing issues, reducing the overall time spent on debugging your design. That wraps it up for this video, and thank you for watching.